Hello geometry students, and welcome to a video that introduces angles, and we're going to classify and name angles. Just like we talked about with segments, we had different ways of naming segments and lines and rays. We had different ways of naming them. We have different ways of naming angles as well. So first of all, what is an angle? Okay, an angle is formed by two rays with the same endpoint. So here you're looking at ray BA and ray BC. They both have the endpoint B. Okay, the common endpoint is called the vertex of the ray. The vertex of the angle. And the rays are called the sides of the angle. Okay, let's name this angle using three letters. Okay, always when you name an angle with three letters, the vertex has to be in the middle. So we've really got two choices. We can say angle ABC or angle CBA. They're both right. So we're going to say angle, and I use the little arc here when I'm talking about an angle because otherwise sometimes it looks like an L. So that's angle ABC. Okay, it also could have been angle CBA. Okay, I almost said B, and it could not be angle, let's say, BCA. So let me just put a little alert warning over that. Can't do that because, as I said here, the middle letter must always be the vertex. Middle letter has to be the vertex. Okay, we can also use a single letter if there is only one angle located at that vertex. So for this angle, there's actually a shortcut, and we could call this just angle B. That's the vertex. And we can only do that because there's one angle there. Now looking ahead, I couldn't do that with something like this angle B because there's so many angles with the same vertex. I have to use the three-letter method. Okay, and then also looking here, there's also this letter method of naming an angle. Okay, so number. So we can call this, instead of calling this angle YTX, which is kind of tedious, that one there means we can just call it angle 1. Okay, and you can see that notation here. So there's three different ways really to notate an angle. There's the three-letter method, as we see right here. There's the vertex-only method if there's nothing else happening at that vertex, simple angle like this one. Or if there's a number in there that's a small number, like a 1, 2, 3, and there's no degree symbol there, then you could name it by that number. Okay, when referring to the measure of an angle, use a lowercase m. So we use this is the measure of the angle. So we have the name of the angle and the measure of the angle. All right, types of angles. This should be reviewed. So four types of angles, really the three most people remember, and that's the smaller angles are acute. Those are smaller than 90. The larger than 90 angles, this is more than 90. So this is less than 90. This is greater than 90, and those are the obtuse. Equal to 90, those are the right angles. And if you have an angle that's more than 90, but it's, like this one, but it's not just obtuse, but it makes a straight line, then that's actually 180 degrees, and that's considered a straight angle. Straight angle. So you got four different classifications for angles. All right, let's look at an example. And I'm just going to actually pause the video and have you guys see if you can answer these questions. Okay, so there you go. So first of all, don't forget all of these are points, and so they're all uppercase. So I don't want to see any lowercase letters anywhere here. The name of the vertex is just the point K. The name of the sides, the ray that starts from K and goes towards L, that's this ray, and the other ray that starts from K and goes towards J. So that's the two sides. Three ways to name the angle. Probably the most important thing that you really understand this here, and that is you can name it just by the vertex, so angle K, and you could name it JKL or LKJ. Okay, and then this appears to be an obtuse angle. Okay, let's try it again. I'm going to pause the video and you fill these out. Okay, there you go. So I didn't mention it up here, but this little mark right here, that you make a square there, that means you're looking at a right angle. So that's just a reminder right here. Hopefully you guys remember that. I know it's been a while. Okay, congruent angles. So So what we can say here is if the measures of two angles are the same, like these both have a measure of 75 degrees, then we say that the angles are congruent. So this is going to look like it's saying the same thing twice, but you have to remember that there's a name and then there's a measure. So if the measure of angle A is equal to the measure of angle B, those are the angle measures. So those are numbers being equal. Numbers can be equal. Shapes can't be equal. Shapes can be identical. They can be the same shape, but they're not considered equal because the word equal, that symbol for equal, refers to numbers. Okay, but when the numbers are equal, when the angle measures are equal, that means the two shapes are identical to each other. You could lay one on top of the other. We're going to talk a lot more about congruence throughout the beginning of this course, but for now this means that angle A is then congruent to angle B. Okay, same shape if they have the same measure. Okay, a little bit more on the introduction of angles. An angle bisector. Now the word bisector, just like it does for segments, means to cut something in equal halves. So a ray that divides an angle into two congruent angles okay, that's what an angle bisector is. So in the diagram to the right, ray BD, that's the ray, BD, is an angle bisector, which means that the two parts here and here are equal. It's kind of hard to tell when it looks like it's just one arc on both, but it's really saying this little arc and this little arc. So if you want to say that two angles are equal, let me just show you here. If they weren't connected, but I just had two angles that were equal, that one looks like it's smaller. So these two would be equal. You could put two arcs there. If you have something else that's equal, you could put one there, and those little arcs inside there, kind of like the tick marks for the segments. Okay, so we could say therefore, and you could say it in either of two ways. It says congruent, so we're going to use the congruence here. So we can say angle ABD is congruent to angle DBC. So we're using that naming process with the vertex in the middle. Don't forget that vertex B has to be in the middle of our angle names. And we could have named this angle DBA, that's the same thing. We could have named this angle CBD. We want to avoid naming this angle B, or else you'd have something that doesn't mean anything that says angle B is congruent to angle B. So we don't want to use the one-point method because there's more than one angle there. Okay, perpendicular lines. So two lines that intersect at a right angle, like these two do. And the symbol for perpendicular is that upside down T. Again, you might not have seen that for a while. So this is how we notate it on a diagram. This is the symbol when we are actually writing a sentence. And so here we can say in this diagram that line L, remember that a line can also be named with a lowercase letter, is perpendicular to line M. Okay, that's perpendicular lines. Perpendicular bisector is a line segment array that is perpendicular to a segment at its midpoint. So the perpendicular bisector is line LM, and it's perpendicular to the segment PQ at its midpoint. So this point right here, which doesn't have a name, that's the midpoint of segment PQ. It is not the midpoint of line LM, because we don't have anything to say that these two are equal. And it's a line anyway, so it's even segment LM, which is drawn here from L to M, we don't know that these are equal, so it's only the midpoint of PQ. So a line segment array perpendicular to a segment at its midpoint. In the diagram to the right, line LM is the perpendicular bisector to segment PQ. All right, let's look at an example. So let's write another name for the angle. Let's just see how many of these questions you can answer. So I'm going to pause it. So referring to this diagram here, see if you can answer some questions. Okay, so first of all, see how you did there. And now let's talk about each one of these. So there's only one other name that you can choose for angle CBF, and that's just to reverse the order. Keep that B in the middle. Okay, the sides of EBD. So I'm going to kind of look at EBD. It's got this side here, which is ray BE, and it's got this side here, which is ray BD. Starts at B, goes in the direction of D. Okay, angle ABC, this whole thing is 180 degrees. That's called a straight angle. Okay, D has more than one possible answer. Give an example of an obtuse angle. So I chose, if I know that this angle here, because this is a right angle down here, I know that angle ABD is 90. So this is adding something to it. It's got to be obtuse. So I chose angle EBD. That was my choice. You could have also chosen angle ABF. Let's see. I don't see any others that you could have chosen here that are definitely obtuse. Actually, you could have chosen angle EBC out here as an obtuse angle. There's probably a couple others, but I might not be seeing them. Okay. Two congruent angles. Only two angles are marked congruent, so we could have chosen these two. So angle ABA, EBA, and angle CBF. Okay, but also you've got a couple right angles here that you could have also said, yeah, they have to be congruent too. So you could have said angle ABD, which is 90, is the same as angle CBD. Okay, so that would be another option. There's only one perpendicular bisector here. So the segment AC from A to C is cut right at the midpoint, and I know that because of this mark and this mark. So I know that AB and BC are the same because it's marked that way. So I know that this is a bisector, and it's perpendicular because it's shown right here to be a right angle. So there's the perpendicular bisector. Okay, let's try one more. You guys try the last one here, and we'll compare answers for example 4. Okay, and there's all of these are all only answers. There's not a lot of choices here, so I didn't have to put any asterisks. For C and D, I did write them in both ways that you could write it. Remember, everything that you're seeing here, except for the names of the classifications, everything you're seeing here is uppercase letters because they're all points. Remember the notation. So this, sometimes students look at this and they think it's the number 4. And after a month of school, they're doing really badly and they say, so I have 4 TZU. And I'm like, oh, okay, that's why you're doing so badly. So this is the angle. This is a symbol for angle. This is another way of saying what you see like here. So angle ZTU. And again, the reason I don't like that is it sometimes looks like an L. And so I prefer the one that looks like a 4 because I think this looks more like an L than this looks like a 4. Anyway, these are the only two options that you have to name these angles. That's what I was talking about earlier when I say you can just name an angle by a number if it's a small number and it does not have the degree symbol on it. Let's see, two perpendicular lines. There's no options there. It's this line and this line. However, you can name the lines. As you know, you can name these lines differently. So you could technically have chosen any 2 points on this line. So you could have called it line YT, and that's still the same line. So I'm going to put an asterisk there because technically you can name it in more than one way. As far as the angle bisector, these are the two congruent angles. Angle 2 and angle 3 are congruent. And so this ray TU is the angle bisector. Okay, I hope you found this video helpful.